Standard deviation for a frequency table. For data in a frequency distribution table, calculating standard deviation requires adding columns to the table. The formula for a standard deviation for frequency tables is standard deviation equals the number of data values multiplied by the sum of frequencies times x squared, bracket, the sum of the frequencies multiplied by x, bracket squared, divided by n, bracket n subtract 1, all square rooted. Example 1. Calculate the mean and the standard deviation for the following data. Alright, so what I've done is I've copied that table over onto this Word document. And what I've done is I've separated the lower class limits and the upper class limits into two different columns. So we have 50, 69, 70, 89, 90, 109, 110, 129, 130, and 149. And then I found the midpoints. So X is the midpoint, and the midpoint is found by adding the lower class limit, which is 50, to the upper class limit, which is 69, which is equal to 119, and you divide by 2 will give us 159 as the midpoint. The next midpoint is found by using the same process, so 70 plus 89 is 159, divide by 2 is 79.5. Then we have 90 plus 109 equals 199, divide by 2 is 99.5. The next one is 110 plus 110 plus 129 is 239, divided by 2 is 119.5. The next one is 130 plus 149 divided by 2 is equal to 139.5. So that's how we find the midpoint, or what x is equal to. N is the total number of frequencies, so we just add up. So n is equal to the sum of all frequencies, and that's equal to 2 plus 33 plus 35. So we're just adding up 2 plus 33 plus 35 plus 7 plus 1. And this is equal to 78. All right, and then we have to find our x squared. So all that I did was I took 59.5 and I squared it. So 59.5 to the power of 2 is equal to 3,540.25. 79.5 to the power of 2 is equal to 6,320.25. 99.5 to the power of 2 is 9,925. 119.5 to the power of 2 is 14,280.25. And then 139.5 to the power of 2 is 19,460.25. So that's how I found x squared. So now I have my frequencies and I have my x squared. So the next column we can find, and I'm going to put this in italics, fx Okay, so we can do fx squared, and I've actually already tabulated this in Excel, so I'm just going to copy and paste this over into my Word document. So basically what I did is I took the frequency and I multiplied it by x squared, and I found this product right here. So I can insert a symbol, which is my multiplication symbol. So f times x squared equals all of these products here. I'm going to add one more column to the bottom. It would be great if I could just move this up one little bit. I can move it all down. Okay. So, okay, so I'm going to have my total column going as well. And my total frequency, if I add them all up, there's 78 in total, which is equal to n. So that's what my n is equal to, is the sum of all frequencies. I want that to be lowercase n, okay? And then my sum of my f times x to the power of 2, I already have that calculated in my Excel spreadsheet, which is this value right here. So I'm going to copy and paste that into my Word document just for display purposes. All right, so I know what this value is, the f dot x squared. I know what n is. Now I need to find what f dot x is. So I'm going to copy, not x squared, just x. So f dot x is equal to basically this column multiplied by this column. So I actually did this in Excel. The command was B2 times C2, so it's the frequency times the midpoint is equal to this column right here. So this is where you can use Excel to your own advantage just by using B2 times C2, or the frequency times the midpoint is what f dot x is. Oh, undo. There we go. And now, now we can paste. Now we can actually paste all this information into the table. So I'm going to delete this column. And so I'm just going to insert a page break. There we go. Okay, so now what we can do is start working with our formula. So S is equal to the square root of, so 78 times the sum of 6,815,000. No, that's 600,000. 81 or 681,578.5, subtract okay, so this is what our formula is leading us to right here, is basically this number right here. So whatever 78 times 681,579.5 is equal to 53,163,201, subtract whatever 7,201 squared is, which is 51,854,401, divided by 78 times 77, which is 6,006, and this is all to the square root. All right, so 53 million, let me clear my calculator, 53,163,201, subtract 51,854,401 equals 1,000,000 1,308,800 divided by 6,006, all to the square root. Divide by 6,006 equals the square root of 217.915. Keep a couple extra decimal places. And the square root of that number, is equal to 14.76. So this is the standard deviation of this table. So the standard deviation equals 14.76. So what IQ scores are unusually low? So first we'd have to find also the mean of this table as well, which is a different formula altogether, and I'd have to review that formula. So what is the formula for oh yes, there's the formula for the table, which is x bar is equal to the sum of the frequencies times x to the divided by the sum of the frequencies. Okay, so I'd have to find the average and then do plus or minus 2 standard deviations. All right. Just finding the midpoints at this point. So 70 plus 89 equals 159 divided by 2 equals 79.5. 90 plus 109 divided by 2 equals 99.5. 110 plus 129 divided by 2 equals 119.5. 130 plus 149 divided by 2 equals 139.5. So the frequencies, which would be 2 times 59.5 plus 33 times 79.5 plus 35 times 99.5 plus 119.5 times 7 plus 139.5 times 1 over the sum of all the frequencies. So the sum of all frequencies is 2 plus 33 plus 35 plus 7 plus 1 equals 78. So 2 times 59.5 plus 79.5 plus 99.5. So 59.5 times 2 plus 79.5 times 33 plus 99.5 plus 35 plus 119.5 plus 139.5. So this equals 7,201 over 78. That equals 7,201. 8 equals 92.32. What IQ scores are unusually low? So that would be the average minus 2 standard deviations, which would be 92.32 minus 14.76 equals, or minus 2 times this would be equal to 62.8. What IQ scores are unusually high? So it would be X bar plus 2. So any scores that are any IQ scores that are less than 62.8, IQ scores that are greater than this quantity. So it would be 92.32 plus 2 times 14.76. So 2 times 14.76 equals 29.52. So that's 92.32. 29.52. So that's 121.84. So IQ scores that are greater than 121.84 are considered unusually high. So this is a way of determining the standard deviation and X bar of a frequency distribution table.